Today we're going to be talking about piecewise functions and how we graph these, how we evaluate them. To start with, what is a piecewise function? It is a function that is made up of different pieces. Okay, so there's multiple parts to it. There's multiple parts of the graph, different things that we need to look at. That's why it's called a piecewise function. It's like we're kind of piecing these different parts together. So if we look at, the first thing we're going to talk about is evaluating a piecewise function. Kind of finding that answer, finding that output value of a function. So you're going to see some notation kind of like this. The f of x equals 2x minus 1 if x is less than 2. Now we also have this 3x minus 5 if x is greater than or equal to 2. These are domain parameters. Remember, your domain has to do with your x values. So whenever we're evaluating these, I want to think about two things. First of all, identify what part of the domain is it in. Is it less than 2, or is that number greater than or equal to 2? And then we can do what we call plug and chug. Put the number in there, and then see what it evaluates out and what our answer is. So if we're looking at this first one, evaluate f of negative 5. Remember, this is an x value. So we want to compare this negative 5 to these numbers up here. This is our first step of identifying the domain. If negative 5 is less than 2, which it is, we want to use this top equation to solve this. So we would go 2 times negative 5 minus 1, which ends up being negative 11. The second problem, we want to evaluate the f of 0. We start up here looking at our domain. Is 0 less than 2? Yes. So we want to use this top equation again. So 2 times 0 minus 1. This one equals negative 1. Now I want to look at f of 2. So is 2 less than 2? It is not. It's equal to 2. It's not less than. But it is greater than or equal to 2. So this time we want to use this bottom equation. So it would be 3 times 2 minus 5. So this one actually equals 1. And then finally f of 5. F of 5 is greater than or equal to 2. So I want to use this bottom equation again. 3 times 5, 15. And then 15 minus 5 is 10. So we're able to evaluate it with those numbers like that. And then jumping ahead to another problem. We can have as many pieces of the function as possible. Like in this one actually equals, there's 3 pieces. So in order to evaluate it the same way, put 0 in. Is 0 less than 3? That's the equation we have to use. So we plug 0 in, and we have to evaluate this. So 4 times 0 plus 8 ends up being 8. If we want to evaluate the f of 3, we find out that we want to use a middle equation, because 3 equals 3. 2 times 3 is 6, and 6 minus 5 is 1. And then because 10 is greater than 3, we have to use this bottom equation. Negative 5 times 10 is negative 50. So that's how we evaluate these functions. Now if we want to graph these, it's a little bit more in depth than what we've done in the past. The first thing we're going to look at, and when we start off, many of these are going to be lines, but hopefully we can identify that both of these, 2x minus 1 and 3x minus 5, are lines. So when we graph these, it's not going to be a line that goes on forever like we're used to doing. These have definite endpoints or beginning points. So I kind of look at this. I see that there's 2 equations, or there's 2 pieces to our graph. Which means I want to create 2 xy charts. So this first one I'm going to put in green. Hopefully you can see that. The second one I'm going to put in black. So with this top equation, there's a definite domain or x values that we need to start with. The first one says x is less than 2. This means we have to start with 2 here. When we plug it in, 2 times 2 is 4. 4 minus 1 is 3. We have our first point. Now, in order to draw a line, we need at least 2 points. So now I want to pick another x value that's less than 2. So I want to pick the easiest point possible. I'm going to pick 0, because zeros are greater. If I plug 0 in here, 2 times 0 is 0, then minus 1 is negative 1. I can now graph this line, and it's actually going to be a ray. We're going to start with this point right here. Now we have to think about inequalities. Less than, greater than, equal to. Because this is less than, this first point has to be an open circle. So at the point 2, 3, if I draw this down, 1, 2, 1, 2, 3. I'm going to put an open circle there. And then at 0, negative 1, this is a regular circle. I start with my starting point, and I draw down. And you see that the arrow is only going in one direction. I have to do that with my other graph as well. Again, because this is greater than or equal to 2, I have to start with this 2 as well. If I put 2 in the bottom equation, 3 times 2 is 6, minus 5 is 1. I now want to pick a point that's bigger than 2, which is, I'm going to pick 3. 3 times 3 is 9, 9 minus 5 is 4. My starting point of 2, 1. Because this is greater than or equal to, I want to use a closed circle. So at 2, 1, it's going to be a closed circle. At 3, 4, I'm up here, I can now draw my line. You will notice that these lines will not overlap. Because if they did, it would violate the vertical line test. So these will never overlap, they will never touch, because this is open and this is closed, it's still a function. So we'll do one more. Now this one, again we notice there's two pieces to the graph. Because we're starting at negative, because x is less than or equal to negative 3, I have to start at negative 3. When I plug it into this equation, I also get negative 3. Now I want to pick another point that's less than negative 3. So another point less than negative 3 is negative 4. When I pick negative 4, I think I get negative 5 there. Because this is less than or equal to, this first point will be closed. So at negative 3, closed circle, negative 4, negative 5, start from here, and our graph goes down in this area. The second equation, again, because this is x greater than negative 3, which means it's going to be an open circle to start with, I have to start with negative 3. When I plug it in, I end up with a positive 3. Now I can pick any point greater than negative 3, so I want to make it easy. I'm going to pick 0. When I put 0 in, this cancels out, so I have 0, negative 6. So I'm going to start at negative 3, positive 3, and with an open circle, and 0, negative 6. Just down there, and then draw my line. And we just graphed a couple piecewise functions. Hopefully this helps.